Greetings there, Mr. Sutton here, bringing you the Pre-Cal Honors 2-1 Part 1 homework solutions on solving polynomials by factoring. For this problem, you have to really resist the urge to divide by x because you might be dividing by 0. So instead, we're going to subtract 64x from both sides, leaving us with 0 on the other side. And now we're going to factor out that x as a common factor. So taking that out leaves me with x squared minus 64. And I've got some options here. If I wanted to, I could solve the stuff inside here by square rooting, but I'm going to do something different this time and just factor it a little more. So let me bring down this x, and I can split this up into x plus the square root of 64, so x plus 8 and x minus 8. That's just the a plus b, a minus b shortcut. Setting each of these equal to 0 and solving, we have x equals 0, negative 8, and for this last factor, positive 8. For this problem, we notice there's no common factors we can take out. We notice there's 3 terms, and this looks to be in quadratic form. The first exponent is twice the second, and then we have a constant in there. So we're going to treat this like a quadratic, only we're going to use x squared instead of x. So if this were a quadratic, I would try factoring it. Numbers that multiply to negative 36 and add up to negative 5. Let's see, 1 and 36 wouldn't work, neither would 2 and 18. 3 and 12 is closer, but still not there. 4 and 9, if I had x squared plus 4 and x squared minus 9, 4 plus negative 9 would give me negative 5x squared there. So now let me solve each of these individually. And I'm just going to solve both of these by square rooting. So for this first one, subtracting the 4, I can say x squared must have a value of negative 4 if I'm trying to zero this thing out. And then square rooting both sides. Since we're square rooting a negative, we get an I. So this is going to be x equals plus or minus 2i. And then over here, I can write x squared equals positive 9 if I add 9 to the other side. Square rooting both sides of this, we have x equals plus or minus 3. For this problem, I can't take out any common factors. I always try to do that first. But I do notice we have x to the 4th, x squared, and a constant. That's quadratic form. So I can just try factoring this like a quadratic and use x squared instead of x. So let's see here. Factors of 54 that add up to negative 15. Well, there's 1 and 54. That's not going to work. Neither does 2 and 27. Let's see here. 3 and... what is it, 18? Well, that's not going to work because they have to both be the same sign since it multiplies to positive 54. What else goes into 54? Well, there's 6 and 9. Yeah, that adds up to 15. So I can split this up then into x squared minus 6 and x squared minus 9. Setting each of these equal to 0 and solving, if x squared minus 6 equals 0, that means x squared could equal 6. And square rooting both sides of that equation gives us x equals plus or minus radical 6. If x squared minus 9 equals 0, that means x squared has a value of 9 as well. Square rooting that gives us x equals plus or minus 3. For this polynomial, first thing we always try to do is take out a common factor, and it looks like these all have x's, so we can pull an x out of there. That leaves us with x squared plus 3x minus 10, and this stuff inside here, this quadratic, can be quickly solved by factoring. Numbers that multiply to negative 10 and add up to 3, let's see, 1 and 10 won't do it. How about 2 and 5? Negative 2, positive 5 would do it. So we have x minus 2, we have x plus 5, and then just setting each of these equal to 0 and solving, we see that x equals 0, 2, and 5, negative 5. On this problem, trying to solve from all my complex roots here, very first thing I'm going to do, no matter what technique I use, I'm going to want to subtract this 12 to get 0 on the other side. Because factoring or whatever else, you need this thing to be zeroed out. I am going to try to factor this. I notice this is in quadratic form. There's no common factors I can take out, but we've got quadratic form. We have an x to the 4th, an x squared, and a constant. That means I can treat this like a quadratic when I factor it, only I'm going to use x squared wherever I would normally use x. So looking for numbers that multiply to negative 12 and add up to negative 4, what could those numbers be? 1 and 12 doesn't work. 2 and 6, if I have negative 6 and positive 2, that would add up to negative 4. So I'm going to split this up then into x squared minus 6, x squared plus 2. Again, I'm using x squared instead of just normal x, because this has to all multiply out to give me x to the 4th here. Now, solving each of these individually, if x squared minus 6 equals 0, that means x squared equals 6, because you can add the 6 to the other side there. And then square rooting both sides, we see x equals plus or minus radical 6. So those are two of our 4 solutions. And then over here, I see that x squared could also have a value of negative 2. Square rooting both sides of this, we end up with x equals plus or minus I radical 2, because you have that negative inside the radical. On this problem, I noticed that I have a common factor of x that I can take out. In fact, I could actually take out a 3x if I wanted to, and I'm going to do that. That'll help me start to solve this thing. So that leaves me with an x squared plus, this is going to be 10x, plus, let's see, 72 divided by 3. That's going to be, well, it's 69 divided by 3. I know that one. That's 23. So this would be 24. And I see that I can actually factor that quadratic inside. Factors of 24 that add up to 10. 1 and 24 doesn't work. Neither does 2 and 12, because they have to have the same sign. But how about, let's see, 3 and 8? No. 4 and 6. There we go. So I can bring down that 3x and split this up into x plus 4, x plus 6. Setting each of these factors equal to 0 and solving. If 3x equals 0, then x equals 0. If x plus 4 equals 0, that's going to be negative 4 for x. And this last factor gives me negative 6 as a solution.